The first type of factoring is a type of factoring called factoring out a common factor. The basic idea is pretty simple because it's the reverse of something you're already pretty good at called distribution. An example here is shown. 3x squared is being distributed into 4x to the fifth minus 7x plus 3. And you know how this works. You take 3x squared times 4x to the fifth, and that's where the 12x to the seventh comes from. And 3x squared times negative 7x, that's where the negative 21x cubed comes from. And 3x squared times 3 is where the 9x squared comes from. Factoring out a common factor is just the reverse of that. It's a little trickier. You have to look at 12x to the 7th minus 21x cubed plus 9x squared and see that all of those have a 3 and all of those have an x squared, so you can undistribute the 3x squared out in front. But as long as you're pretty good at distribution, you'll probably be pretty good at factoring out a common factor right off the bat. So I'm going to give you a practice problem to begin with right away. Get out a piece of your own paper, pause the video, and see if you can do it. Go ahead and try. Now I'll show you how to work it out. If you look through here, you'll notice that all of these are multiples of 2. So you factor out a 2, leaving 10x cubed plus 15x squared minus 5x plus 20. No, I'm joking with you. That's not the right answer. Well, it's kind of the right answer. It's not entirely wrong. That is a correct factoring, but it's not a complete factoring. It's incomplete. It is true that 2 goes through all of those, and you can factor a 2 out, but that's not all you can factor out. There's a much larger number that you can factor out. So yes, of course, what I would love for you to do is pull out the largest factor that can be pulled out of a polynomial. In this case, it would be 10. And that would leave you 2x cubed, 3x squared, minus x, plus 4. Let's try one that's a little more challenging. And again, you should pause the video with your own piece of paper, try to work out the problem, and then press play and I'll work it out myself. All right, much more challenging problem here. First of all, there's a minus sign that runs through all of these, so we're going to factor the minus out first. For the numbers, 18, 12, and 24, the biggest common factor to all of those would be 6. For the a's, we can only factor out a single a. And for the b's, we can factor out a b squared. So from the first term, that would leave us 3a to the 4th. From the second term, that would leave us 2b. And from the third term, we would have 4a b to the second. Now that's a lot to keep track of. There's a lot going on there all at once. It's real easy to get an exponent wrong or get a minus sign where you should have a positive sign. There are a lot of very easy mistakes to make here. So my suggestion is always check your work. And checking your work here is actually very, very simple. In fact, it's so simple that we're going to be very strict when we're grading your factoring problems. If you get a factoring problem wrong, that's a serious mistake because it's so easy to check. The checking here is to distribute the 6ab squared back into all three of these. So negative 6ab squared times 3a to the 4th, you get negative 18a to the 5th b squared. Negative 6ab squared times 2b is negative 12ab to the 3rd. And negative 6ab squared times 4ab squared is negative 24a squared b to the 4th. Does that match the original polynomial? It sure does. Then we factored correctly. So it's very easy to check. Don't ever allow yourself to have a wrong answer on a factoring problem. Here's one more to try on your own. And again, the way this works, get out a piece of your own paper, pause the video, and in a second, I will work the problem. All right, so when you look through these three, you probably noticed with the 35 and the 42, as you were reading through, 35 and 42 have a common factor of 7, but 7 doesn't go into 48. So for the numbers, it turns out there is no common factor. The only common factor we can pull out here is xy. And that'll leave you 35x from the first term, negative 42y squared from the second term, and 48xy squared from the third term. And again, if something seems wrong about that, check, multiply the xy back in, make sure it matches the original polynomial. Let's talk about the more difficult type of factoring by grouping, or factoring out a common factor, called factoring by grouping. The basic idea for factoring by grouping is a very simple basic idea, illustrated by this example here. And yeah, this isn't a tricky problem. Don't think that you're going to be tricked into making a mistake or something. This is an obvious one. Look at that. Common factor is capital A. And when you factor out the capital A, you have 3x minus 2 left over. The thing that's tricky about factoring by grouping is usually that students panic. They don't let the problem be this simple because they freak out. Here's an example of a situation where a student might freak out. They see that funny squiggle thing, and maybe they recognize that that's the Greek letter delta. Or not. It really doesn't matter, honestly. Look at this problem and compare it to the one a second ago. You'll notice this isn't actually a different problem. The common factor is that funny squiggle thing, and you're not even sure how to write it. You just try to copy it down as best you can. But whatever it is, you factor it out, and you'll have a 3x minus 2. So look at these two problems. If you could do the first one, you should be able to do the second one, right? Well, let me do one more example to help break your mental habits of expectation and how things should look, because here's a problem that will probably make you giggle a little bit. Yeah, I'm obviously being silly. 3x smiley face minus 2 smiley face. But again, compare it to the previous two problems, it's not really different. There is a common factor. The common factor in this case is smiley face. Yeah, I know, that's silly. But you factor out the smiley face, and you have 3x minus 2 left over. So the point I'm trying to make here is the thing that's common can be anything. It can be a capital A, it can be a delta, it could be a smiley face. So the place where people stumble, where they don't connect this idea to the next idea, is problems like this. 3xa minus 2a, 3x delta minus 2 delta, 3x smiley face minus 2 smiley face. Those are all the same things as each other. This one down here is also all the same thing as those previous ones. This is just like the capital A. This is just like the delta. This is just like the smiley face. Whatever it is, you factor it out. So here, we're not factoring out an A, we're not factoring out a delta, we're not factoring out a smiley face. We are factoring out 2x plus 1. And that leaves 3x minus 2, just like the previous three problems we did a second ago. So 3x anything minus 2 anything, you factor out that anything. The real problem is not that. If every factoring by grouping problem was presented to you looking like this, you would succeed every single time. The problem is we don't usually write problems out already pre-set up in this format. What usually happens is this 3x would actually be distributed in there, and you'd have 6x squared plus 3x. And this negative 2 would be distributed in there, and you'd have minus 4x minus 2. So the problem you would actually be asked to factor would be 3x or 6x squared plus 3x minus 4x minus 2. So the trick there is to take that and break out the groups. The 3x times 2x plus 1, you need to break that out of the first two terms. And the negative 2 times 2x plus 1, you need to break that out of the second two terms. So we call that grouping. You group the first two terms, you group the second two terms, and you factor whatever you can factor out of the first two terms. So that would be a 3x out of there. And from the second two terms, you could factor out a -2. And then you've got this common factor, just like we had a second ago. So the basic idea is make groups of two terms. From each group of two, factor out a common factor, and then look at those groups as having an overall common factor that can be pulled out in front of everything. Let's compare it to this example here. So I'm going to pause, give you a second to work this out on your own piece of paper, then press play on your video and try it again. All right, so from the first two, we can factor out, let's see, 5x squared. That'll leave you 2x minus 5. And from the second two, 2x minus 5, there's no common factor. So here's the kind of little cheat that we do to make this work out. We factor out a 1. Yeah, I know, it's total cheating. Factoring out a 1 isn't really factoring anything at all. But here, it's a good idea because look, we now have this common factor in both groups. Both groups have a 2x minus 5. So factor out the 2x minus 5. And that'll leave you 5x squared plus 1. If you think you're getting the hang of this, try this challenge problem here. Again, I'll pause, give you a second. You should pause the video, try it on your own piece of paper, and then press play. All right, if you're doing this one right, you're going to make groups of 2. From the first group, you would pull out a 5x to the 4th, leaving x minus 1. From the second group, you would pull out an x squared, leaving x minus 1. From the third group, you would pull out a 3, leaving x minus 1. And your common factor here would be x minus 1, going through all of those. Leaving 5x to the 4th from the first group, x squared from the second group, and 3 from the third group. One last point before I let you go has to do with problems like this. Doesn't look that different from the ones we've done so far, so you would probably try to deal with it the same way we've dealt with the previous two problems. You would make two groups. From the first group, you would obviously see the 3, and there's an x, and you would factor out the 3x, and that would leave you 2x plus 1. From the second group, you would see that there's a 2, and that would leave you negative 2x plus 1. And then you would notice that these don't match. If those don't match, factoring by grouping fails. And that's sort of the bad news. Factoring by grouping does not always work. There are situations where factoring by grouping fails. So in this case, you cannot factor this one. Factoring by grouping does fail sometime. And if the polynomial you're working with does not factor, what we do is we call that polynomial prime. A polynomial that doesn't factor is called a prime polynomial. Just like with numbers, if a number doesn't factor, it's called a prime number. So, if you're trying to factor using the techniques we're going to learn any place in Chapter 5, and the thing doesn't factor, we're going to call it prime. That's not just for factoring by grouping. That's for all factoring we're going to learn anywhere in this entire chapter. See you next time for section 5.2.